So recently, my YouTube channel Tech with Tim hit 1 million subscribers, and I thought it would be a cool idea to create a program that launches fireworks to celebrate. So I'm going to show you how we build this program in this video. I'm going to give you a full tutorial, and we're going to be using Python and Pygame to do this. Now, I am assuming that you're familiar with Python. This is not a beginner Python tutorial. However, if you don't know Pygame, that's fine. I can kind of teach you the basics here. Now, everything I do in this video is fully customizable, so you can change the spread, you can change the colors, you can change the pattern of the firework. This is meant to just give you a solid foundation and base for a program like this. And then, of course, please go ahead and customize it and tweak it as you please. So I think that that's all I have for this introduction. Thank you again to everyone for subscribing to this channel. I hope you enjoyed the tutorial, and we'll get into it after a quick word from our sponsor. Before we get started, I need to thank Mailgun for sponsoring this video. Mailgun lets you send transactional or bulk emails effortlessly, regardless of your business use case. Mailgun's ease of use, world-class support, and powerful APIs empower smart development teams to reach customers at scale. Mailgun can even prevent fake signups, remove invalid email addresses, and overall improve your email delivery and conversion rates. Mailgun helps hundreds of thousands of users around the world to provide connected experiences and drive smart results. With Mailgun's comprehensive analytics, your team can use a data-driven approach, so you're never guessing how your emails are doing or if they're being delivered. With Mailgun, it's never been easier to build connected experiences, and you can try Mailgun today by using my link, mailgun.com/techwithtim. Thanks again to Mailgun for sponsoring this video. Alright, so let's get started with this tutorial. I'm going to use Visual Studio Code for my editor. You can use whatever you'd like, and I'm going to assume you have Python installed. Now, the first thing we need to do, and actually the only installation step here, is just to install Pygame. So go to a terminal or a command prompt window and type pip install Pygame like that. Now, for many of you, this command may not work. If it doesn't, I will leave 2 videos on the screen and linked in the description that show you how to fix this pip command for both Mac and Windows. Now, if that didn't work for you, just try pip install Pygame as well. These are just kind of some quick fixes. Those videos will show you everything if these don't work. You can also try Python 3-m pip install and then Pygame, and alternatively Python-m pip install Pygame. Again, if none of those work, then check the videos in the description or the cards on the screen. Okay, so now that we have Pygame installed, we can actually start coding. Before I do that, though, I just want to bring up the finished product again and just quickly walk you through what we actually need to create here for this program to kind of function properly. So looking at this here, you can see that we have kind of firework launchers. We then have the actual firework itself that kind of goes up in the air, and then that firework explodes, and we have kind of projectiles coming off of that. So we need to kind of model this in our program by having 3 separate classes. We're going to have a class for the launcher. We're going to have a class for the actual firework going up, and then another class for all of the projectiles. And that's going to allow us to do this very dynamically and essentially create as many fireworks as we want once we kind of set all of that up. So hopefully that made sense, but that is what we are going to do. And the first thing I'm going to do for us here is just set up kind of the Pygame window and the main game loop and all of that. And of course, I'll walk you through that as we go. So I'm going to say import Pygame, pygame.init here, just to initialize all of the modules. And then we're going to say width, height in all capitals, because this is going to be a constant value for the width and the height of the screen, is going to be equal to, and I'm going to choose 800 and 600. But you can choose whatever width and height you want. And if this is too large, then of course, just make it a bit smaller for your screen. Next, we're going to set up a Pygame window. So I'm going to say win is equal to pygame.display.set_mode. And whenever we do this, we need to pass a width and a height. So I'm going to pass the width and the height variable, and this will create a window for us where we can draw all of our stuff. Now that we've created a window, we usually want to add a caption for this. So I'm going to say pygame.display.set_caption like that. And I'll just call this fireworks ! Okay, now that we've done that, I'm just going to define a few constants here that we're going to use. First one's going to be FPS. This is the number of frames per second we're going to run at. I want this to be 60, so that's what I'm going to do. And then I'm going to paste in here a bunch of colors. Now this is going to be red, green, blue, yellow, purple, pink, white, pink, and I think I have one other one in here. Either way, doesn't really matter exactly what they are. They're just RGB values. And if you guys are wanting to copy this yourself, I'll leave a link with all of the code in the description for you. Okay, so now that we have that set up, let's just create a function that can kind of show our window and we can quit the window with. So I'm going to say define main. This is the function we're going to run as kind of the entry point of our program. And then down here, I'm going to say if _name is equal to main. then call the main function. If you're unfamiliar with this, it just means if you actually run the Python module itself, as opposed to import the Python module, then run this function. So really we don't need this because we're not going to be importing it, but it's just good practice to put this here, because if we were to import this module and we didn't have this, like we just put main, say, down here, outside of the if statement, then it would run this entire code, even though we might not want it to do that. Okay, so now that we have the main function here, what we're going to start writing is just our main event loop. So in any Pygame program, we need something that's constantly running in the background that can essentially do things like increment our counters, draw stuff on the screen, handle maybe button presses or key presses, all that kind of stuff. And that's what we're setting up here in this main function. So I'm going to say run is equal to true. I'm going to say clock is equal to pygame.time.clock. This is the object we're going to use to make sure our while loop that I'm going to implement in a second here runs at a certain speed. So I'm going to say while run, and I'm going to say clock.tick, and I'm going to tick FPS. So what this does is essentially limits how quickly this while loop can run, so that we're going to be running at 60 FPS no matter how fast the computer is that's running this code. So for example, I have a very fast computer here, and if I weren't to put clock.tick, then everything would happen like instantly on my screen. It would just go super fast because this while loop would not be limited in its speed, and it would go as fast as a single core on my processor could go. Whereas in this case, when I put the clock, now it limits it to 60 frames per second, giving us a somewhat consistent feel across different devices. Okay, so now that I've done that, I'm going to say for event in pygame.event.get, and this is kind of the event loop that I'm talking about here. What this is going to do is loop through all of the different events that are occurring. So if I press a button, if I hit a key, if I move the mouse, all of that type of stuff, and then we're going to check for a certain event. So I'm going to say if event dot type is equal to pygame.quit, then what I'm going to do is say run is equal to false, and I'm just going to break out of this for loop. Now run equals false, we'll just set this variable to false, so then we will exit the while loop and we'll stop doing this. And what pygame.quit is when you hit the red X button on the Pygame window, which you'll see in a minute. Okay, so then I'm going to come down here outside of my while loop. I'm going to say, all right, well, if we're outside of the while loop, then we can quit Pygame, and then we can just quit Python as well. So we just quit and quit. You don't really need both of them, but it's fine. We'll just put them here. Okay, so now that we have done that, we can actually run the code, and we should see a Pygame window pop up. So let's run it here. And notice that we get a fireworks exclamation point as the caption and kind of a black window, nothing's happening. Now, if I click X, it should close, and that's because we implemented this here in the event loop. All right, now that we have done that, the first thing we can set up is a way to actually kind of draw objects on our screen. So I'm going to say define draw, and I like to separate everything out into different functions just so it keeps it clean. And inside of this draw function is where I'm going to handle all of the drawing for my program. Now, we're not going to have much in here, but for now, we'll just put win.fill, and I'm going to fill this with black because it's kind of like the sky, right? So I want black to be the background. And then I'm going to say pygame.display.update, and then we'll come back to this later on. But for now, I just want to call the draw function right here at the end of my while loop. And again, we will kind of continue and add to it as we have stuff to actually put on the screen. Right now, we're just filling the background with black. Okay, so now that we've done that, what I'm going to start implementing is my launcher. So remember, we have kind of 3 objects here. In fact, we can write them out. We have the launcher class. We're going to have the actual firework class, which of course will be launched from the launcher. So put past there. And then we're going to have projectiles, which are kind of, I guess, like the parts of the fireworks, right, that are coming off of it. So I'm going to say projectile like this, and I'm going to do these all as classes, assuming that I spell them correctly. It'll just make things really simple for us. So we have the launcher, the firework, and the projectile. And what's going to happen is the launcher is going to create the firework, and the firework is going to create the projectile. So these classes are kind of all working together in the program. All right, so let's start with the launcher here. I'm just going to define a few class variables that I want to use in here. So I'm going to say width is equal to 20, and height is equal to 20. And then I'm going to say my color is equal to gray. Now, whenever you see me type something in all capitals, that's just denoting that I don't want to change this value within the program. I want this to be a constant, and that's kind of the convention in Python. So these are going to be the constants related to the launcher class. So all of my launchers will have a width and height of 20, and they'll be a gray color. Feel free to change that if you want. All right, now that we've done that, we need to take in some parameters in our constructor. So I'm going to say define __init self, X, Y, and then frequency. Now the frequency is going to be how quickly we're creating new fireworks. You could do this randomly if you want, but I'm just going to make it a set frequency. So every X milliseconds, we're going to launch another firework out of that launcher, and we can change that for each launcher. So some could be like rapid firing, some could be firing every 10 seconds or 20 seconds, really up to you, but that's why we're putting this parameter here. So now that we've done that, we're going to say self.x is equal to x, self.y is equal to y, and then self.frequency is equal to frequency. And sorry, this is just going to be x. Now, x and y is going to be the starting position for the launcher. That's where we're going to place it on the screen. And just quickly, before I go any further, let me run this code here. One thing you have to note is that in Pygame, the coordinate system has 0, 0 at the top left-hand corner. So right here where my mouse is, that's 0, 0. If I were to go all the way to the right, then that would be whatever the width of the screen is and 0. And if I were to go to the bottom of the right, it would be whatever the width of the screen is and then whatever the height of the screen is. Coming over here, it would be 0 and then whatever the height of the screen is. So in the middle is kind of like half the width and half the height. Keep that in mind because if you want to go upwards, for example, you need to subtract from your y. If you want to go to the right, you need to add to your y, which is what we're going to be doing here. Okay, so now that we have our initialization, we're just going to place a few other things in here. So I'm going to say self.start_time is equal to time.time. And since I'm using that, I need to import the time module. So I need some way essentially inside of my launcher class here to determine how much time has elapsed since I launched the last firework so that I know when to launch the next one. So that's kind of why I'm putting that here. And then next, while we're in the initialization, I'm going to say self.fireworks is equal to a list, and that's going to store all of the fireworks that are currently on the screen that we want to be drawing and kind of moving upwards, right? So that's what we have for launcher. Okay, so next, let's implement a draw method. I'm going to say define draw, self, and then I'm going to take in win. And win is going to be the surface that I want to draw this launcher onto. And yeah, that's what we're doing here. So we're going to call draw for the launcher every time we want to draw its contents. So inside of here, I'm going to say pygame.draw.rectangle because I want to draw a rectangle for my launcher. You can do it in any shape you want, but I think a rectangle makes sense. And I'm going to say win, and I'm going to say self dot in all capitals color to reference this variable here from the class. And then I need to pass an actual rect object, which is going to be an x, y, width, and height. So I'm going to say self.x, self.y, self.width, and self.height. All right, so that's all I need for the rectangle. And for now, that's good for our launcher. So let's actually just draw the launcher on the screen, make sure that's working, then we'll move on to the next step. So for our draw function, since I want to do all my drawing in here, I'm going to take a list of launchers. And inside of draw, I'm going to say for my individual launcher in launchers, like that, I just want to do launcher dot draw, and I'm going to pass to this the window. So win here is a global variable, right? We have that, and we're just passing it to the draw function, and then we'll draw this rectangle onto the screen. Okay, so that's good, but we need to now create a list of launchers. So I'm going to say down here, launchers is equal to, and we'll just go with 1 for now. And for the launcher, what do we need to pass? An x, y, and frequency. And the frequency, we're going to put in milliseconds. So let me just make a comment here with ms so that we know it's milliseconds. Okay, so for the launcher, we want to place this at maybe 100x, and then I want this to be at the bottom of the screen. So to put it at the bottom of the screen, I need to place it at the height of the screen. The issue with this, though, is that when I draw an object in Pygame, I start drawing from the top left-hand corner. So if I were to draw it at 100 and then the height, you wouldn't actually see the object because the top left-hand corner of the object would be right at the bottom of the screen. So instead, I need to subtract whatever the height is of the launcher so that I draw it, in this case, 20 pixels above the bottom of the screen, and then it kind of fills down to the bottom. So I'm going to say height minus, and then this is going to be launcher, if we could spell that correctly, dot, and then height. Now, the reason why I like the class variables is because I can just directly access them on the class name itself, right? Okay, so we have 100, height minus launcher height, and then we need some frequency, and in this case, let's go with 3 seconds, which would be 3,000 milliseconds. Okay, so now we have launchers. Now we just need to pass this to the draw function, so we'll do that there, and then we'll run the code, and let's see, we should get a launcher, and we do. We got one right there. Okay, so the launcher is functioning. Next thing we need to do is actually create a firework every X seconds or so, or every frequency seconds, right? So what I'm going to do here is make another method, and I'm going to call this loop. Now I'm going to call this every single frame. So I'm going to call this once every while loop iteration, and it's going to take care of, creating a new firework and moving the fireworks and all of that. So inside of here, I'm going to say loop self, and then I'm going to say the max height, or the max width, sorry, and the max height. Now the max width and the max height, I'm assuming is going to be the screen height and the screen width, or the screen width and the screen height. And the reason we need this is because once a firework goes off of the screen, we want to remove it, right? We don't want to be drawing something that's not on the screen. So we'll get to this later on, but I just need to put it in the function signature for now. Okay, so the first thing we're going to do here is just determine if we should be launching another firework. So I'm going to say current time is equal to time.time, and the way I determine how much time has elapsed is I just take the current time and then I subtract from it whatever the time is that we started at. So I'm going to say time elapsed, like this, is equal to the current time minus the self.start time. So now I'm going to say if my time elapsed, and then this is going to be multiplied by 1,000 because this is going to give me the time elapsed in seconds, is greater than or equal to the self.frequency. Remember, the self.frequency is in milliseconds, so we're just converting to the same unit. If that's the case, then I'm going to reset my start time. So I'm going to say self.start time is equal to the current time, and then I'm going to say self.launch, and this will be a method that we need to write. So let's just write the stub for this now. Define launch, self, and then in here we'll create a firework. But again, we're not going to do that this second. Okay, so that's what will happen. This will essentially launch a firework for us every X seconds or so. But now what we need to do is we need to actually move all of the fireworks. Now, I'm just going to leave a comment. So move all of the fireworks because we don't have the fireworks created yet. So it doesn't really make sense to be moving them. But that's what we're going to do here in the loop. Okay, so I apologize because I do actually have to write a fair amount of code before we can really see any progress on the screen, just based on how the program works. So just bear with me. I think this is simple enough that we don't really need to test this. And we're going to go to the firework class now and then hopefully kind of view the firework moving up once we finish coding this. So for the firework, we need an initialization as well, and we need a few class variables. So the first class variable I'm going to have is a radius of the firework because it's going to be circular. I'm going to make this 10, and then I want to know the maximum number of projectiles that should be launched from a firework because we'll make this slightly random. So I'm going to say the maximum number of projectiles we want to have is 50, and the minimum number of projectiles is going to be, let's go with 25. So we'll have something in this range when we actually generate the projectiles. And then we want to have a projectile velocity. So I'm going to say projectile vel is equal to 4. And that's essentially how quickly it moves in any given direction. All right, next we're going to have an initialization. So we're going to say init, and we're going to take in the self, the x, the y, and then we need the y velocity of this firework because we're going to be moving it upwards, right? And we need to know at what speed we want to move it up. That's different than the projectile velocity. The projectile velocity is the projectile is coming off of the firework, whereas this is actually moving the firework upwards until it gets to its launch height, or its explode height, which is what I'm going to take in here. So I'm going to say explode height is the next thing that I want. And then for my firework, of course, I need a color. So for all of these, I just need to put my self before them. So self.x is equal to x, self.y is equal to y, self.yvel is equal to yvel, self.explode height is equal to explode height, and self.color is equal to a color. Okay, so that is our initialization. We're going to just put a few other things here as well. We're going to say self.projectiles is equal to an empty list because similar to the launcher, we need to keep track of all of the projectiles associated with this individual firework. We're then going to have self.exploded, and this is going to be equal to false, and that's just going to indicate whether or not we've actually exploded the firework because that will change the way that we draw it, right? Okay, so now that we've done that, we are going to write a few methods. The first method that we'll write is our draw. So I'm going to say define draw. I'm going to take in myself. I'm going to take in my window. And for now, we can just draw a Pygame circle, but I only want to draw this circle if I have not yet exploded. So I'm going to say if not, self.exploded, then I just want to draw a circle representing the firework because it's kind of going up in the air. So I'm going to say pygame.draw.circle, excuse me, window, self.color. We need to then pass the center of this circle, which is going to be the self.x and the self.y position of this individual firework. And then lastly, we pass the radius, which will be self.in all capitals radius. We'll be referencing the class variable here. And I accidentally did something in my terminal here. I don't know what this is. Let me just quit that. Okay, there we go. All right, so now we're back. We have draw. Now, if we have not exploded, we'll do this. However, no matter what I want to do is just loop through all of my projectiles. So for projectile in self.projectiles, and then I want to draw the projectiles. And again, doesn't make a ton of sense because I don't yet have the projectiles defined, but just like on all our other classes, we'll have a draw method and we'll have win. So we'll loop through all of the projectiles and we'll draw all of them if we have them, right? And you'll see how we create those in 1 second. Okay, so that's all we need for now. Actually, I lied. We're going to add one more method, and this is going to be move. So just like we need to move the firework upwards. So that's what this function is going to do, or this method. So I'm going to say define move. And here again, I'm going to take this max width and this max height, just so that I know when this firework, I should stop drawing it on the screen. Again, we'll get to that in a second. Okay, so I'm going to say if we have not exploded yet, then what I need to do is I want to move this upwards. So I'm going to say self.y plus equals the self.y velocity. And that's just going to essentially be moving our firework in whatever direction this y velocity is. So if this velocity is negative, we're going to move upwards because we're subtracting from the y. If it's positive, we'd move down. Now, of course, we want to move up, but I want to make this dynamic. So rather than having a minus equals, I just do a plus equals. And now if you pass a negative velocity, you go up. If you pass a positive, you go down. I guess it would work the same in the opposite direction, but that's fine. Okay, so we're going to move our y, but now what we need to do is determine if our y is at the explosion height, because we need to explode the firework and create the projectiles once we get to a certain height, right? So I'm going to say if the y, so self.y, is greater than or equal to the self.explode height, then what I'm going to do is say self.explode, and I'm going to explode the firework. So that means we need an explode method. So I'm going to say define explode self. And then in here, we can actually just say self.exploded equals true. And then we would need to create the projectiles around this firework. All right, so I want to test a bit of this before we go any further. So I just need to write a bit of code that's going to move this firework and draw it. And we'll do that from within the launcher class. Then once we have that, we can test and make sure that the firework is moving properly. Then we'll deal with the projectile. The projectile creation is the most complicated just because we have to do a bit of math to determine like the angle to launch off the projectiles. Anyways, let's go back to launcher for now. Let's create our fireworks. Let's move our fireworks and continue here. So for our launch, we need to make a firework. So the first thing we need to make our firework, or one of the things we need, is a color. So I'm just going to say color is equal to random.choice, and then I'm going to choose from the colors list that we defined above. And now that I look at it, this can be all capitals. And I need to import the random module so we can use that functionality. So let's go back down here and let's change this to be all capital colors like that. Okay. So now we have a color. The next thing we need is an explode height. So I'm going to say the explode height is equal to random.randRange. And then I'll just hard code these values. It probably would be better to have them in a variable, but for now, I'm just going to go with something like 50 and 400. So we're going to be picking a height near the top of the screen that we want to explode at. Recall that the lower the number, the higher we are on the screen. So 50 is very close to the top of the screen, and 400 is about in the middle of the screen. Actually, I don't know what the height is, but it's close to the middle. So that's the explode height. And then next, we want to make our firework. So I'm going to say firework is equal to, and then firework, and we need to pass to it the x, y, and then the explode height. We also need to pass the velocity and the color. So the x is going to be self.x. The y will be self.y because it's just going to be launching from wherever the launcher is positioned, which are these two values. Then we need to pass the velocity. In this case, I'm going to pass -5. And then next is the explode height. So we'll pass that. And then the color. Now, one thing I'm going to do is just add a value here. This is going to be self.width divided by 2. Now, the reason for this is that I'm going to be drawing a circle. And when I draw a circle, I draw from the middle of the circle, right? Recall when we had the circle, where was it? Here. This is the center position that we're passing. So since it's the center and not the top left, if I were to draw it from self.x, then it wouldn't look like it's coming out of the center of the launcher. So that's the reason why I have the self.width over 2, so that I'm now centering this. I'm moving it, in this case, 10 pixels over to the right, so that the center is actually in the middle of where the launcher is, and that's why I'm doing self.width over 2. Okay, anyway, so we create the firework here. Now we're going to say self.fireworks.append firework. We need to add it to that list for it to actually be drawn and all of that. And now I'm going to go to my draw function. and I'm going to draw all of my fireworks. So I'm going to say for firework in self.fireworks, we're going to say firework, it should just be firework like that, dot draw, and then we need to pass the window. Now, in the same fashion, I'm just going to copy this for loop here, and I'm now going to move all the fireworks where I have this comment. So I'm going to say for firework in self.fireworks, and I'm going to start moving them. So to move them, I'm going to say firework.move, and then I will pass to it the max width and the max height. Again, we haven't used that yet, but we will shortly. That's why we're passing it along. And next, I am going to just check something to make sure that I'm not drawing a firework, or in this case, actually moving a firework, if it has exploded already. So let me just write this out and then I can explain it more clearly. But I'm going to say if firework.exploded, remember that's a Boolean value we have on there, and the len of firework dot, and then this is going to be, what is this, projectiles, is equal to 0, then I'm going to remove this firework. So this is going to be a bit weird. Just bear with me for 1 second. I'm going to say fireworks to underscore remove is equal to a list. And I'm going to say fireworks, and then underscore to underscore remove dot append firework. And then let me just finish this up and then I'll explain. For firework in fireworks dot remove self dot fireworks dot remove, and then firework. Okay, apologies for going quickly there, but I just need to get it all down before I could really articulate what's going on. So what we're doing is looping through all of the fireworks. We are then moving all of the fireworks. We need to call this move method to move them upwards, right? And this loop method will call from inside of main. We'll do that in a second. Anyways, we're moving all of them. The thing is, I don't want to be moving a firework and doing unnecessary computations if the firework is kind of off the screen. So I'm saying if the firework has exploded and we don't have any projectiles, so that would mean that the projectiles are off of the screen. We're going to remove them from the projectile class, or from the firework class, sorry. So we'll deal with that later. But if the firework exploded and we have no projectiles, there's nothing we really need to be doing for this firework. So let's just remove it. I don't want to be drawing something on the screen if I don't have to. And in fact, if I were to continue to draw this on the screen or to continue to move it, then I'd get a ton of lag as the program continued on, because I'd have all of these fireworks that are off of the screen that I'm moving and drawing, etc. So that's why I'm removing them. Now, the reason I can't just directly do self.fireworks.remove is because I'm currently looping through self.fireworks. So I could actually fix this by just making this a copy, but I don't want to do this. So what I'm doing instead is making a list here, fireworks to remove. I'm going to append all of the fireworks I want to get rid of, and then I'm just going to have another for loop here, where I remove all of the fireworks after I have looped through them. So you don't want to be mutating something that you're iterating through. So that's kind of why I'm not doing that here. And instead I'm doing the second for loop. Some of you will probably have a more elegant solution for this, but for now, this is fine. All right, so I actually think that's all we need for the launcher class. We have a launcher. Now what we need to do is move the launcher or call the loop method. So from main, I'm going to say for launcher in, not holders, launchers like that. And then we'll simply call launcher.move, and we'll just pass the width and the height of the screen as the max width and the max height for our fireworks. Okay, so quick recap here. We have our main function. This is the main event loop. I'm drawing all of my launchers and just doing all of the drawing here, and I'm moving all of my launchers, or sorry, this needs to be .loop, not .move. So I'm calling the loop method on each one of my launchers. Inside of this loop method, I'm calculating the time elapsed. If it's been past the frequency time, so past 3 seconds or whatever we set, we'll launch another firework. Then what we do is we loop through all the fireworks, we move them, and we check if they're exploded and if we don't need to be moving them or drawing them. If that's the case, we add them into this list, and then we remove them here at the end. And that's pretty much it. And then within the firework, we're just moving the firework based on kind of the logic that we have inside of here and making sure that we're not moving it if it's already exploded. All right. Let us run the code here and let's see what we get. We should see a ball being launched here from the launcher and just moving upwards every few seconds. Now, it doesn't look like that's happening, so I might have to go back to the drawing board here. Yeah, let me have a look at what's wrong and I'll be right back. All right, so I made a pretty silly mistake here. I'm saying if self.y is greater than self.explode height instead of the move method for my firework, then I'm going to explode. Now, the reason this is incorrect is because my y is actually going to be greater than my explode height in every situation. So because I have this condition here, I'm instantly exploding my firework, which means I'm instantly not seeing it because I don't have any projectiles to shoot off. So I just need to change this to be a less than or equal to the explode height because that's actually correct. If we're less than the explode height, that means we're above it on the screen. So we do want to explode. So just change that symbol from a greater than sign to a less than sign, or just copy the code from the link in the description. Anyways, let's run this here. And now hopefully this should work, assuming I didn't make any other errors. And we got an issue. It says tuple object is not callable. Okay, so I just forgot a comma here when I'm drawing my circle. So let me just add the comma and let's try this again. And fingers crossed, 1, 2, 3, and there we go. We see an orange ball go up, and then at the explode height, it's gonna go away because that's what we've set it to do. And this would work for all of our launchers. Notice that we're getting kind of a random explode height. Great, so that's what we want. Now that we have that, let's deal with the projectiles and actually having something interesting be on the screen, because obviously this is kind of the boring part until we get to the projectiles. So let's create some projectiles. So for the projectile, we are going to have just a rectangle. So we're gonna have a width, in this case, I'll say that's 5, and a height, and I'll just go with 10. Now, I also want to kind of fade these projectiles. Like I want to have a transparency to them so they appear like they're fading off in the screen. And the way I'm going to do that is by having an alpha property, and I need to decrement this alpha property. So I'm going to say the alpha decrement is equal to 3, just meaning I'm going to subtract 3 from the alpha, and alpha is like your transparency property. So you start at 255, that's totally opaque. And then as you go down to 0, you are completely transparent. Hopefully that's clear, but that's what we're doing with the transparency in a minute. So I'm going to define my constructor here. I'm going to take in myself, my x, and my y. And then to move, I need my x velocity. I also need my y velocity. And lastly, I need my cover. So since we want to move potentially on a diagonal here, not just up or down, I need 2 velocities, one for both direction. And if we move both of them, then we can move kind of in a diagonal line, right? So here we'll say self.x equal to x, self.y is equal to y, self.xvel, xvel, self.yvel, self.color. It's very nice to have a great autocomplete. We're also going to set manually an alpha here of 255, and then we'll decrement that as we move the firework. Now this actually will be pretty simple, the firework itself. We're going to say define move. We're going to say self, and then we actually don't need to take anything else. We can just say self.x plus equals the self.xvel. And then we'll say the self.y, same thing, plus equals the self.yvel. And then we're going to say the self.alpha is equal to, and this is going to be the maximum of 0, and the self.alpha minus, and then this will be the self.alpha decrement. Now, the reason I need the maximum here is because I cannot have a negative alpha. If I had a negative alpha, that's going to give me an error. It's going to crash the program. So if we get to a position where the firework is still on the screen, we're still drawing it, but the alpha is less than 255, then we'll just make it 0. So it will appear like it's not there. All right, next we're going to have draw. Now inside of draw, we're going to take self and win, and we're going to draw something here, but I need to make another method. This is actually going to be a static method. And this is going to be draw alpha. So I'm going to say define draw, and I'm going to actually say rect alpha like this. And the reason I'm writing this is because to draw a surface with transparency in Pygame is a little complex. So we're going to put it in its own method. So we have a static method because it doesn't actually need access to any of the properties from this class. And I'm going to take my surface, my color, and my rectangle, and I'm just going to draw on the surface with a specific color a rectangle that has transparency associated with it. Anyways, you'll see what I mean as I code this out. So I'm going to say that my shape underscore surf or surface is equal to Pygame, and I'm going to make a surface. So if you're unfamiliar with Pygame, everything that you draw is a surface. Now the window here, like this is actually a surface, but I'm creating a surface and I'm going to enable transparency on the surface, which is what you have to do for it to actually accept an alpha property when you're drawing it. So I'm going to say Pygame dot and then rect, and I'm going to pass to it a rect here, and we're going to treat this just as a 4-item tuple, which is x, y, with height, but I need to convert this to an actual rect object to work with the surface object in Pygame. Again, it's just 4 properties, x, y, with height, but it needs to be a special object, so we're wrapping it there, and we're going to pass actually the size, which will give us the width and the height, which is what the surface needs. Okay, next we are going to enable transparency. So to do that, we're going to say Pygame, and then this is going to be src, and then alpha like that. Like that, there you go. And that will allow transparency for the surface. So now that we've done that, what we're going to do is apply a color to this surface. So we're going to say Pygame.draw dot, and then we're going to draw a rectangle. Where are we going to draw it? Well, we're going to draw it on the shape surface. We are going to draw it with a specific color. And then I'm actually going to pass here the shape underscore surf like this dot get underscore rect. So it's a bit weird, but what I've done is created an empty surface, which is the size of the rectangle that's passed in. Then I'm going to draw to this surface whatever color we pass, which will have a transparency property associated with it, as well as the size of the rectangle of this surface. So I'm just filling the entire surface essentially with a color that has transparency. And then lastly, I'm going to take my actual surface, which in this case will be the window, and I am going to blit the shape underscore surface and the rectangle like that. The rectangle is the position that I want to put this at. Okay, I know this seems a bit weird. If you don't understand, it's totally fine. I actually just took this code from Stack Overflow. I'm trying my best to explain it to you. What blit will do is it will take one surface and put it on another surface. So we're saying the surface, which is going to be the window, dot blit, and then we're taking the shape surface, which is a transparent rectangle, and we're placing it on there, and the position we're placing it on there is the rectangle position, which will give us the x, y, etc. So now from draw, all we need to do is say self.draw rect alpha. We're going to pass the window, we're going to pass the color, and this is going to be self.color, but we're going to say plus, and since self.color is going to be a tuple, we're going to add to it another tuple that contains the alpha property. So I'm going to say self.alpha and then a comma, because whenever you surround something in parentheses, if you want it to be a tuple, you need to have a comma after. So that's what we're doing that for. And then for the rectangle, we're going to pass self.x, self.y, self. And then this will be the width and self.height. All right, so the complexity here is done now with the projectile. That's all we need for that class. Now we need to create projectiles in some type of pattern and then move them around on the screen. So inside of explode is where we want to create our projectiles, and I guess we can start doing that now. So we're going to do two patterns. One of them is going to be a star, and one of them is going to be a circular pattern. So let's start with the circular pattern. I'm going to say define create circular underscore projectiles, and for here we're going to take in self, and we're going to take in the number of projectiles that we want. Now what I need to do is I need to determine, let's go back here for 1 second, the x velocity and the y velocity of every projectile that I have such that it appears in a circular pattern. So let me just quickly go to my drawing screen here. If I can pull this up, I always forget which one it is. Windows Ink is right here. Okay, whiteboard, and let's just have a look at how we actually do the math here. All right, so I made it to the whiteboard here, and I'm going to give you a quick trigonometry lesson on how we actually do this. So we have a circle. We're familiar with the fact that a circle has 360 degrees worth of angles. What we want to do is launch fireworks off kind of at an even displacement or an even distance around the circle, right? We want them to come off like completely evenly from the circle, and to do that, we need to use a little bit of trigonometry. So we know the circle has 360 degrees, and something you need to know, many of you may know this if you're familiar with trigonometry, but if you're not, then this is the following. So 360 degrees is actually equal to 2 pi. 2 pi is what's known as the radian, or the radian of the angle 360. So rather than using degrees, we use radians in like computer math and just in general trigonometry. So just be familiar with 3 pi equals 2 pi. Or 360, sorry, equals 2 pi, and that means that 180 equals pi, and 90 is going to equal pi over 2. So if we're looking at kind of our quadrant, let me just see if I can move this over here. Whenever we're dealing with angles, I like to just draw out kind of a quadrant here. We have our quadrant. We know there's 360 degrees, and we also know that because we have 4 90-degree angles here. The first angle we have is 0. Then this, based on our radians, is going to be pi divided by 2. Then we're going to have pi. Then we're going to have 2 pi, actually. We're going to have 3 pi over 2 because we need 1.5 pi. And then as we come all the way back here, we're going to have 2 pi as the angle. Okay, so just keep that in mind. These are the different angles that we have based on this kind of quadrant, right? Where, again, pi over 2 is 90, this is 180, this is 270, this is 360. So now we're going to say loop through all of our fireworks, and we're going to essentially pick angles from 0 to 2 pi that we want to launch these projectiles or fireworks off at. So we're going to have, a bunch of different angles that we select that we want to launch the fireworks off at. So hopefully you're following so far, but we're going to be launching at a bunch of different angles. So once we determine the angle that we want to launch at, we need to then determine the X and the Y velocity that we need to create to move the firework in that direction. So if I have an angle here, right? Let's just do this. Let's create a right triangle. So actually, let me just redo this. Again, I'm drawing with my mouse, guys, so just give me a break here. We want to launch in this direction. We have some angle theta, and we know the velocity v that we want to launch this firework off at. We want to launch it at, 4 pixels per second or something along those lines, and we know the angle. Now, if we know that information, we can solve for X and Y, and that will allow us to determine the X component or the X velocity, and the Y velocity we need to move the firework at to move at this angle. So how do we now solve for X and Y? Well, there's a few little shortcuts for equations that I like to write down. So I have SO, Ka, and then I also have TOA. Again, please excuse the handwriting. This is kind of horrible. But I have SOHCAHTOA, and this stands for sine is equal to the opposite over the hypotenuse. This is cosine is equal to the adjacent over hypotenuse. And then TOA, that's tangent is opposite over adjacent. All right, so I've written these equations here. Now we know what they mean. And let's just go through opposite, hypotenuse, and adjacent. So the hypotenuse is the longest side, which is V. Opposite is the opposite side to the angle, so kind of what it's facing, which is right there. And then A is the other angle, so not the hypotenuse, or sorry, the other side, so not the hypotenuse and not the opposite. So in this case, that's adjacent. So what I need to do is find a way where I can solve for O. In this case, it's going to be Y, using values that I know. In this case, I know the value theta and I know the value V. These are kind of like question marks in a sense, right? So if I want to solve for Y, I look at my equations and I find something where I have the angle and I have the hypotenuse. In this case, we have it here, sine, opposite, hypotenuse. So I have the angle, I have the hypotenuse, and I'm going to solve for O. So I say that the sine of theta is equal to, and then that is going to be the opposite over my hypotenuse, but my hypotenuse is a value v, which is a velocity that we'll know. Let's say v is equal to 4 or something, okay? So now if I want to solve for O, all I have to do is multiply v by the sine of theta, and that gives me the value for O. And in this case, that's the velocity that I need to move at in the y direction going upwards. Hopefully you're following. Again, hard to do this without a pen and paper because I'm doing this with my hand and mouse, but hopefully you get it. And the same thing now is going to apply for the value x. Now, when I want to solve for x, I'm going to use the equation cosine is the adjacent over the hypotenuse, and really all that means is that I'm going to multiply the cosine of the angle by x as opposed to the sine of the angle by y. I'm going to do this in code, so it should make more sense, but that is practically the trigonometry lesson for today that I needed to give you. All right, so now that we are done with the math, thank God, we can go back to create circular projectiles, and I can actually start writing this out. So I'm going to say my angle difference, or angle diff, is going to be equal to, and then this is going to be math.pi multiplied by 2, which remember is 360 degrees, divided by the number of projectiles that I have, because I want to evenly move around the circle, and that's how I get this, right? How many degrees I should essentially shift for every projectile. That's what this value is. I'm then going to create a variable. This is going to be current underscore angle is equal to 0. Now next, I'm going to determine my velocity, and I'm going to do this slightly random. I'm going to say random.rand range like that. And then I'm going to say the self.projectile vel -1 and the self.projectile vel +1, just so I get some variance in the speed at which my projectiles move at. Now it's very slight because I'm just going down 1 or up 1. You can adjust this if you want. But that's what I'm doing for velocity. Now what I need to do is I need to loop through all my projectiles. So I'm going to say for I in range, and then the number of projectiles that I have, and the number of projectiles we will randomly generate in a minute. Now that we have that, we need to determine the x velocity and the y velocity of the projectile. So I'm going to say the x velocity is equal to math dot, and then this is going to be sine. And I don't actually know if I have math imported yet. I don't, so let's import math. Okay. Come here, and we say the x velocity is math.sine of the current angle that I have multiplied by the velocity. Just like I showed with the equation, that's what we're doing. Then I'm going to say the y velocity is equal to math.cosine of the current angle multiplied by velocity. Okay, so we have x and we have y. Now we need to determine the color. So for the color, I'm just going to say this is random.choice. And then this is of colors, just randomly selects a color for us. And then I'm going to say self.projectiles.append. And I'm going to create a projectile like this. And to create a projectile, I need to pass my self.x. This is where it starts. Self.y. I also need to pass my x velocity, my y velocity, and my color. And let's just confirm here. We have x, y, x vel, y vel color. Looks good to me. Okay, so we create a projectile. And then lastly, we need to increment our current angle by the angle difference so that every single projectile is slightly shifted. In this case, it's going to be to the right, and we will complete 360 degrees worth of projectiles being shot off at kind of different angles. So that's what this will do. Now, inside of explode, I will just call this method. So I will say self.create circular projectiles, but I need to pass to it a number of projectiles. So I'm going to say my num projectiles is equal to, and then this is going to be the random.rand range. And this will be the min projectiles and the max projectiles, but don't forget the self. Okay, there we go. So now we actually have pretty well everything we need, assuming we pass num projectiles, to now view a circular pattern of projectiles coming off of our fireworks. Again, I apologize that it got complex at the end there, but I do try my best to explain everything that we're writing rather than just making you write it out with me, hence the trigonometry lesson. So let's run the code here and prepare to be amazed. Assuming that we didn't mess anything up, let's have a look here, and we got an error. Okay, so not as amazed as I thought. We have projectiles is not defined. And the reason that would be the case is because, where is this? We are on line 100. This is why. We need to say projectile, not projectiles.draw. So I had an S, need to just remove that. And now we should actually be able to draw them. So let's run the code now and see if we got any other errors. Okay, so we launch it and there we go. Okay, so you can see that a rectangle is being created. The issue right now is that we're not actually moving the projectiles. So that was kind of an oversight by me. We need to move them. Otherwise, they're all going to be placed in the same place and we're not going to see them move. So to move the projectiles, we need to go to our firework, which is right here. And we need to now implement something in the move method. Apologies, guys. Totally overlooked that. But I'm going to say, similar to what we did with the fireworks, projectiles to remove is equal to an empty list. And then I'm going to say for projectile in self.projectiles, I'm going to say projectile like this dot move. And that's all we need. And then I'm going to check if the projectile is off the screen. And if it's off the screen, I'm going to remove it. So I'm going to say if projectile.x is greater than or equal to, and then this is going to be the max width. That's why we had to pass this here. Or the projectile.x is less than 0, then what I want to do is remove it. And the way I remove it is projectiles to remove dot append projectile. I'm going to say elif the projectile.y is greater than or equal to the maximum height, or the projectile.y is less than 0, then the exact same thing, projectiles to remove dot append projectile, and then we will loop through all of those. So we'll say for projectile in projectiles to remove, and then we're going to say self.projectiles.remove the projectile. And notice my autocomplete did a fantastic job there because I'd written the same thing previously. All right, so that's what we need for move. Pause the video if you need to complete that. I'm going to run the code though, and hopefully, fingers crossed, we will see the projectiles moving. So let's have the firework ball come up, and there you go. We get the projectiles going and fading off into the distance. So let's create a few more launchers just so we get a nice kind of aesthetic effect here. And then I will implement the star pattern, and then we're pretty much done. So let's just copy this launcher. Let's make 4 of them. Let me just save this so we have some more space. Let's change the frequency to be like 4, 2, and maybe 5. And yeah, we also need to change the X value. So let's change the X to be 300, 500, and 700. And now let's run the code and see what happens with 4. Okay, so they're not completely evenly spaced out, but that's fine by me. And we can see that they're all going to launch and work properly, and we shouldn't experience any lag because we are removing all of this stuff once it's kind of off the screen and we no longer need to be drawing it. Sweet. So let's do the star pattern. The star pattern, I'm not going to show you the trigonometry for because I'm sure I've already bored many of you with that. I'm just going to write it out, and yeah, hopefully I can do a good enough explanation. So for the star pattern, it's going to be slightly different than the circular pattern. What I want to do is launch projectiles kind of at a different speed in the same 8 directions. So since it's a star, I'm just going to pick 8 different angles that I want to launch at, and then launch at different speeds so that it looks like projectiles are kind of moving like with each other in the same direction. So I'm going to say define, and then this is going to be create underscore star underscore projectiles, like that. I won't take in the number of projectiles because for this one, we actually need to set it to an even number. All right, so inside of create star projectile, I changed it from start to star, by the way, so we spell it correctly. I'm going to do the following. I'm going to say my angle, like this, underscore difference, so underscore diff is equal to, and then this is math dot pi divided by 4. The reason I'm doing that is because we want to have 8 separate angles. That's just what I've decided. So if we do math dot pi is the angle difference, and that will give us 8 unique ones, because if we know that 2 pi is 360, then math dot pi over 4 is 1/8 of 360, and that's what we're doing this for. Next, we're going to have our current angle. That's going to be equal to 0. Then I'm going to say for I in range, and then we need to just decide manually how many projectiles we want to have. So in this case, I'm going to go with 64 projectiles, and ideally we'll get 8 projectiles going in each direction. Now, since these projectiles are moving in the same direction, they need to have a different velocity or a different X and Y position. Otherwise, we're only going to see one projectile in each direction. So the way that I'm going to fix this, I'm going to say that the velocity is equal to, and then this is going to be the self dot projectile velocity plus, and then this is going to be I mod, and actually this is going to be a little complicated to do, but I'm going to do I mod 4. Is this going to work? I don't know if this is going to work properly. So actually, scrap that. I'm changing this back to I mod 8. I've just been confusing myself with how I'm going to do this. Okay, I'll explain why that's going to work in a second. But let's continue. So we have vel is equal to that. And I'm actually going to change this to be 1 to 65, just so that my modulus operators work as I expect them to. And now I'm going to calculate the x velocity and the y velocity. So the x velocity is going to be the math.sine of the current angle multiplied by my vel. And then for the y velocity, it will be this, just the opposite with cosine. Next, I'm going to have my color, random.choice colors, and then I'm going to say self.projectiles, .append, not star projectile, although good guess, autocomplete, and this is going to be self.x, self.y, x, y vel, and color, and then we need to increment our current angle. So I'm going to say if, and then this is going to be I plus 1 mod 8, and actually I don't need the plus 1 because I started at 1, so we're going to say if I mod 8 is equal to 0, then the current angle plus equals the angle difference. So essentially what we're doing here is every I guess what is this going to be, every 8 projectiles, we're going to increment the angle. So we're going to launch 8 projectiles in the same direction with a different speed, so we create kind of this star-like pattern on the screen. That's what this will do. I can't really explain it much more than that. So now what we need to do, though, is figure out a way to programmatically decide if we want to do create circular projectiles or create star projectiles, and we'll just use a random number to do that. So I'm going to say if random.randint, and we can just say 0, 1 is equal to 0, then we will do this. Otherwise, we'll do the star projectiles. So no, self dot create star projectiles, like that. Okay, so I think that's actually all we need. That should complete the project. So let's run this now and see if we get any star projectiles on the screen that are moving in the correct direction. Okay, so there you go. We got the star, and notice how the star is like super fast because of the way that I've done the velocity, and that we're launching 8 in that direction. Now, if you wanted to kind of make these less exaggerative, what you could do for the star is, instead of doing 65, you could just do 32. Now, if you change this to 32, you have to change the velocity accordingly to be mod 4. So you're doing half of what you did before. And sorry, this needs to be 33. because of the number of projectiles. Now, to fix this, we can just say num projectiles, and we can do this programmatically instead. So if I make this now, in the case 32, then I say num projectiles plus 1, and then rather than I mod 4, I'm going to do I mod, and then this is going to be the number of projectiles divided by 8, because we have 8 unique directions. So now this will just work, and you'll see that we get less going in a direction, and they'll actually end up be going a bit slower too. So let's look at this now, and let's see if we get any stars. All right, so actually I made a mistake here. Now, rather than doing I mod 8, I need to do the same thing, I mod number of projectiles over 8, and then that will work properly, and we won't get the angles cutting off. So let's try this now, and let's see what we get. And there we go. Now we get a proper star, and it's programmatic, and we can change it and mess with the speeds and all of that. All right, this was a long tutorial, guys. I apologize, near the end it did get a bit confusing. I wasn't planning on going that in depth in the math, but I obviously wanted to try my best to explain it to you. Hopefully you guys appreciated this and enjoyed, and now we are officially celebrating together 1 million subscribers. Again, massive thank you to all of you guys for supporting me on this channel. The comments are just amazing. Yes, I don't reply to all of them, but I do read them all, and really, this has just been awesome to hit 1 million subscribers. So thank you guys so much. Hopefully you enjoyed the video. If you did, you know what to do. Like, subscribe, and I will see you in the next one.